So solving differential equations, these are our examples for this. These are probably going to be slightly more difficult than the ones that we have done in the past, even though we have been separating and integrating already. These are probably going to be just a little bit more complicated. All right, so I've got this equation. It says find the general solution. So I need to separate, get my y's on the left and my x's on the right. So what do I have so far? I have x squared plus 4 dy dx equals x times y. Okay? So I need to, first of all, get this y on the left side. So I'm going to divide this y. I need to get all of these x's over on this side. So I will be dividing by x squared plus 4, and I'll be multiplying by the dx. So I'm going to end up with x. I'm going to divide by x squared plus 4. And then I'm going to multiply the dx over there. And then for this side, the dy is going to stay there, but I'm going to divide the y over on that side. So I divided by x squared plus 4 to the other side. I multiplied by dx, and I divided the y to the other side. So now I'm going to integrate. So all I did was separate, get the y's on the left, get the x terms on the right. So now we're integrating. So separate first, then integrate. So the integral of 1 over y is natural log of the absolute value of y. Then over here, this is a u substitution. So we want u to equal the denominator, because I noticed the derivative of x squared plus 4 is 2x. And I've got the x up here, just don't have the 2. So I'm going to let u be x squared plus 4. So I know it's a natural log problem. And then du is 2x dx. So then my dx is du divided by 2x. And so now I'm going to come over here and trade out. So this will be x over u, and in place of dx, I'm having du over 2x, and the x's cancel. So I've got the fraction 1/2, I've got the function 1 over u, and then I've got the bookend du. So the natural log of y is going to equal 1/2, and this is the natural log of u, and then plus c. And now I need to stick my u back in. So I'm going to have the natural log of y equals 1/2. The natural log, and my u was x squared plus 4, and then plus c. All right. So now I would really like to have this solved for y. I want my general, this is a general solution, but I would really like to have it solved for y. So one of the easy things you can do, I can move this 1/2 back here. I can do ln of y equals, this 1/2 can become the exponent right here. So that's going to be the natural log. When I move this 1/2 back here, it's the square root of x squared plus 4, and then plus c. Now, I can't take the square root of x squared plus 4. That's not going to be x plus 2. Because remember, when you do a square root, you have to add all this together first before you take the square root. So that cannot be simplified. So moving that 1/2 to the back makes a square root over the x squared plus 4. So now I can do the e thing that we've done before. Raise both of these quantities to the e. Okay? I'm going to move this plus c over a little bit. Move that plus c right there. All right, and so then this cancels. So we got the absolute value y equals, remember when we have addition, this is the same as a product. So this is e to the natural log of the square root of x squared plus 4 times e to the c, because when you multiply powers, you add your exponents. So I'm just reversing that process. So this e to the c becomes a big C. So I can take my bars off on this side. And these guys actually are going to cancel, the e and the ln, so it becomes square root of x squared plus 4. And so that's my answer. So this e and that ln cancel, so you just have the square root of x squared plus 4, and the e to the c becomes your big C. And once you get that big constant there, you can take the bars off your y. Okay? All right, so that's our answer for that one. So these are just slightly a little bit harder than the ones we did previously, because it's specifically this section on separate and integrate. So we've been doing that already, just not ones as hard. All right, number 6. looks even more difficult. Wooey. All right, so this one says find y of 0, given y of 0 equals 1, find the particular solution this time. So I need to find the general solution first, and then I will use this initial condition to find the particular solution, a specific solution. All right, so I need to keep the y's on the left and move the x's to the right. So let's see what happens when we do that. So we can first move this guy, the xy dx, we can subtract him over to the other side. So that's going to leave us e to the negative x squared, quantity y squared minus 1 dy. So if I subtract all of this over to this side, I'm going to have a negative xy dx. All right? So just move that over there. Well, I still got x's and y's mixed up, so one thing I can do is I can divide this y over to this side. So that'll be y squared minus 1 dy divided by y. So if I just divide this y over to this side, then I can divide this e to the negative x squared over to this side. So I'll have negative x divided by e to the negative x squared, and then the dx. So I kept the y squared minus 1 dy, and I divided this over to the other side. For this side, I kept the negative x dx, and I divided the y over to this side. All right, so now why don't we just simplify just a little bit here. I can split this up and make this y minus 1 over y. Okay, so I can split this up because I got y squared over y, which is just y, minus 1 over y. So I can do that. You don't have to put parentheses around that. And then over here, I can move this e to the negative x squared. I can move that upstairs, and that will become e to the positive x squared. So just doing a little bit of some math with using our laws of logarithms and simplifying. So now I'm going to integrate both sides. All right, so now I can integrate. So the antiderivative of y is going to be y squared over 2 minus the antiderivative of 1 over y is going to be the natural log of the absolute value of y equals. Over on this side, I might do a u substitution. So I'm going to change my color. When we've integrated e, we always made our u the x squared. So I'm going to let u equal the x squared. So that means du is going to equal the 2x dx. So when I solve for dx, that's going to be du divided by 2x. So when I come over here, I'm going to trade out. I'll keep my negative x. This is going to be e to the u because I made the u the x squared. And in place of the dx, I'm going to put du divided by 2x. All right, so I still have y squared over 2 minus the natural log of y. And then over here, the x's cancel. So I'm still integrating. So my coefficient is going to be, looks like negative 1/2 because I have a negative sign, and the 1/2 is in, the 2's in the denominator. So it's going to make a negative 1/2. My function is e to the u. And then I've got my bookend du like we're supposed to have there on the end. All right, so now we're ready to do the antiderivative of that part. So y squared over 2 minus the natural log of y equals, let's see, when I do the antiderivative, I'm going to keep the negative 1/2, keep the coefficient. The antiderivative of e to the u in terms of u is e to the u, and then plus c. So then I'm just going to throw my u back in. So this will be y squared over 2 minus natural log of y equals negative 1/2 e to the, what was our u, x squared. So that's e to the x squared plus c. And this is my answer because we cannot solve for y. So because there are 2 variables of y, and you can't solve for y in this case, so that you would just leave that as your answer. We do have the y's on the left and the x's on the right. So I mean, we kind of have it solved, but we don't have it y equals. All right, so that's as far as we can take that one. A little more complicated type problem, so you're not able to solve it for y equals just because of the complexity of the problem. All right, so we separated the x's from the y's. and went on from there. All right, so then it says, given y of 0 equals 1, find the particular solution. So that means this is x, and my y value is 1, so it's the ordered pair 0, 1. So I'm going to change my color, the ordered pair 0, 1. So we're going to substitute that in there. So y is 1, so this will be 1/2 minus the natural log of 1 equals negative 1/2 e to the x squared. X squared is going to be 0 plus c. So we know the natural log of 1, that is 0. So this just gives me 1/2 on this side. E to the 0, we know that's 1. Anything raised to the 0 power here is 1. So this is negative 1/2 times 1, so that's negative 1/2 plus c. So if you add the 1/2 over on this side, c is going to equal 1. So that means now our particular solution is y squared over 2 minus the natural log of y equals negative 1/2 e to the x squared plus our c, and we found our c to be 1. So here is our particular solution. So remember, this was the general solution where you still have your plus c in there. And this is our particular solution that goes through the point 0, 1. So when you plug a 0 in here and a 1 in for the y's, it makes a true statement. Okay? All right, so when you plug in 0 for x and 1 in for y, it makes a true statement. All right, believe we did all that one. All right, number 7, find the equation of the curve that passes through the point 1, 3 and has this slope. Well, this is just another way of phrasing the same problems. All right, if it says this is the slope, then that means this is y prime or dy dx. This is our derivative. So we know y prime equals y over x squared. So we can replace that with dy dx equals y over x squared. And so we've got to separate again like we've been doing. Separate and integrate. So we need our y's on the left, so I'm going to divide the y. That'll be 1 over y dy. And then I'm multiplying the dx over here, so this will be 1 over x squared dx. Okay? Now, one thing that might make this a little easier to integrate, I can write this as x to the negative 2 dx. That'll make it a little easier to integrate. So now I'm going to integrate both sides. So we know the antiderivative of 1 over y is the natural log of the absolute value of y. On this side, you're going to reverse the power rule. You're going to add 1 and then divide by your new power. So if I add 1, that'll be x to the negative 1. And then we're going to divide by negative 1. So then plus c. So I can write that as the natural log of the absolute value of y. That means put the x in the denominator since it's x to the negative 1. So that's going to move him down here. So that's going to make it 1 over negative x, which is the same thing as negative 1 over x plus c. So there is our general. So this is our general solution. Okay? So what I'm going to do before I get the particular solution, I'm going to go ahead and solve, you put the point in. So let's see, what's our equation we got so far? Let me copy it up a little higher here. So natural log of y, the natural log of the absolute value of y equals negative 1 over x plus c. All right, so this is what we've gotten so far for our general solution. Now you could go ahead and solve for y if you want to, but I'm going to go ahead and use this point first. So y is 3, so the natural log of 3, I don't need the bars because 3 is positive, and then negative 1 over the x value, which is 1, plus c. So that means my answer for c, this is negative 1, so I add it over here. So this will be natural log of 3 plus 1, and that's not the natural log of 4, all right, because it's the natural log of 3 and then add 1, all right? So this is my constant. So that means now my equation is the natural log of the absolute value of y equals negative 1 over x and plus our c value, which this is our c value, natural log of 3 plus 1. Okay? So now let's see here. Now we can solve for y if we want to. We can do our e stuff, all right, because we can make all of these the exponents to e. So these cancel. So it's going to give me the natural log of y equals, And we can break all of these up. So this will be e to the negative 1 over x times e to the ln of 3 times e to the first. Okay? All right. So e to the ln of 3, that e and that ln cancel, so that's just 3. And then, let's see. So this will be e to the, we can put these back together if we want to, because that's not really going to help us. So it's negative 1 over x plus 1. We can just write that as that. Now, this is a positive expression, so y equals that expression. E to any power is positive, so this is going to be a positive answer. All right, so that is our answer. All right, so find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at the point xy. So that means this equation has a slope of y over x squared, and it also goes through the point 1, 3. So that means when I put in a 1 in here, I'm going to get the answer 3. We can verify that real quick. If I put a 1 in here, this is negative 1 plus 1. That'll be e to the 0, which is 1. So I'm going to get a 3 answer. All right. So that was our solution for that one. So this is just separating and integrating. All right, the rate of change of the number of coyotes, N of t, in a population is directly proportional to 650 minus N of t. So where t is time in years. So let's write that equation. It says the rate of change of the number of coyotes, N of t, in a population is directly proportional to 650 minus N of t. So the rate of change, so that would be the derivative, is directly proportional to 650 minus N of t. So the rate of change of the number of coyotes, so rate of change is a derivative. So we're saying the derivative of the number of coyotes, N of t, so that's N prime of t, in a population, is directly proportional, that's where we get our constant of proportionality, to this expression, 650 minus N of t, and t is time in years. All right, so first we need to solve this situation. All right, so this is going to be a dn dt, because I can replace this, k 650 minus N of t. All right, so now I'm going to multiply the dt over to the other side. So this is dn k 650, whoops, that's 6d, 650 minus N of t. I'm multiplying the dt over here to this side. And I'm going to move the N of t stuff over to this side. So I'm going to divide this over here, which I should have done all at once, but that's okay. So this will be 650 minus N of t because my dn is on this side, and then k dt. Okay? So I translated this first sentence into my differential equation. I didn't have to replace this n prime with dn dt. You could just think of that as the antiderivative of it. But I replaced it with dn dt. Multiply the dt over here, bring the nt to be with the n prime of t, and this is what I got here. So then I'm integrating. So I've separated. So I've got my n's on one side and my t's on the other. So I've separated. Now I'm ready to integrate. All right, so this is the derivative in terms of n, where this is the function n here. So this is going to be a natural log situation. The only thing that's going to happen here, the derivative of this expression is going to be negative 1. And I don't have the negative up here, so it's just going to be the negative natural log of the absolute value of 650 minus N of t, which is just n. All right, so the reason I'm putting this negative here is because this is derivative over function, and the derivative of this down here in terms of n is going to be a negative 1. So the only thing I'm missing up here is a negative sign. So that's going to be the negative natural log of this bottom function. Then over here, the antiderivative of k in terms of t will be kt, right? Because this is like a number. This is like having a 3. So the antiderivative of 3 in terms of t is going to be a 3t. So just k is not a variable, it's a number. So it's a constant of proportionality. So the antiderivative of k in terms of t is kt. And then plus c. All right, so now let's see. One thing I can do is I can move this negative over to this other side, which I like to do to get rid of that a little bit. So I like to multiply that over to this side. And so then I can do the e business. Okay. So these cancel. So this gives me the absolute value of 650 minus nt equals, this will be e to the negative kt divided by, because this is subtraction, e to the c, which again, I can write that as a constant, e to the negative kt. And then I can take off the bars here, 650 minus n of t. All right, so now solving for the n of t, it would be negative n of t equals c e to the negative kt minus 650, okay? And then if I multiply the negative n of t is going to be a negative c, which I could just write as a c, but I'll write it as a negative c, plus 650, because I just multiplied. So there's my equation. Now, you'll notice this looks familiar here. This ce to the negative kt, that looks familiar. And the only thing is you got that plus 650, which involves this right here, okay? All right, so then it says when t is 0, the population is 300. All right, so when t is 0, the population is going to be 300. So let's figure out, let me go up here and write, if I can remember that. So we have n of t equals negative c e to the negative kt minus 650, I believe, is what we had. Nope, plus 650, because we multiplied that negative sign across there. So negative c e to the negative kt plus 650. All right. Okay. So it says when t equals 0, the population is 300. So the population is 300 when t is 0. And this plus 650 is going to change my c value, because normally when t is 0, the initial amount is your c value, but we got this plus 650, which is changing the situation a little bit. All righty. So let's see. I plugged in 300 there. I plugged in a 0 for my t. That makes this e to the 0, which is 1. So that means negative c plus 650 equals 300. So negative c, if I subtract the 650, that'll give me negative 350. So c is positive 350. So my equation, n of t, is going to be negative 350, because c is 350, but I have negative c up here. So negative 350 e to the negative kt plus 650. So there's what I got so far. Then it says when t is 2, the population has increased to 500. So now we need to put in a 2 and a 500, and that'll help us find k. So 500 is what I get, negative 350, when I put a 2 in, e to the negative k times 2 plus 650. All right, so if I subtract 650, I'm going to have negative 150 equals negative 350 e to the negative 2k. So I divide by negative 350. That's going to cancel. That'll give me e to the negative 2k equals, let's see if that's a nice little decimal. I don't know if it is or not. No, it's not a very pretty decimal. So I'm just going to write it as, canceled it down to divide by 5. I'm just going to cancel it down to 3/7. All right. So now we're going to take the natural log, right, on both sides. So the natural log of 3/7, the exponent goes to the front, negative 2k natural log of e. We know this equals 1. So negative 2k. So negative 2k equals the natural log of 3/7. So k, we're just going to divide by 2. So natural log of 3/7 divided by negative 2. So this is our k value. All right. So now let's put in, so here's our equation right here. So I'm trying to see it all on the screen at one time so I can write it. So I'm going to change my color again. So n of t is going to equal negative 350 e to the negative, and then we're putting in k. So that's going to make it a positive because that's going to be natural log of 3/7 divided by positive 2 because it's a negative k times t plus 650. All right, so I'm just replacing k right, whoops. I'm just replacing k right here in that equation. So I'm replacing this fraction, which is a negative fraction, but when I put it up here, this is already a negative, so that's going to make it a positive. All right, so now the last part of this question says, find the population when t is 3. So now I'm going to find the population when t is 3. So this is my equation. Looks like a complicated equation, but now we're down to the end here. We want to know what's the population when t is 3. So all I got to do is plug in n of 3. So that's negative 350 e to the natural log of 3/7 divided by 2 multiplied by 3, and then you add 650. So we're just going to type that in the calculator and see what number we get. So I'm typing in negative 350 and then e raised to the whole quantity 3 times the natural log, 3 times the natural log of 3 divided by 7, and then that'll be divided by 2. And then I'm going to add 650. And so that's giving me 551.802. All right, so let's check this out and see here. At 0, we had 300. At 2, we had 500. So now at 3, we have 551. So it's still growing, but it's slowing down. All right, so there's my answer, 551.802. So that one was a lot more difficult than one that we have done before. All right, so I wrote the problem out. The rate of change of this had to be directly proportional to this expression, so I wrote that out first. And then I separated and integrated and found an equation. So then I found this equation. And that was after even I found C, because that was a C. No, it wasn't. All right, so then I found when I put in 0 and 300, that's when I found C, being this. All right, and so then I substituted back in the C value. Okay, so that gave me this equation. Then I needed to find the K, so that's why they gave me the second piece of information. When T is 2, the population was 500. So that's how we ended up solving for K. And instead of making a big long decimal, I just left it as the natural log of 3/7 divided by the negative 2. So then I plugged that in again to the equation for the K value, and this was our final equation for this situation. All right. And so then the last part of the question said, what's the population when T is 3? So I substituted in a 3. I just typed all this in the calculator, and that's the answer I got, 551.802. So yeah, that one was a little bit more involved, but separate and integrate. Just so you understand, separate and integrate. Separate and integrate means separate your variables, one on the left, the others on the right, and then integrate the problem. All right? So that's what it means to do. So there are some example problems for you to do over separate and integrate. All right, so always get your variables separated on each side, then integrate both sides. General solution still has the plus C in it. If they ask you for the particular solution, that's when they give you the initial condition, and you have to solve for C. That's the particular solution. So good luck.